Hello everyone. In this video we will be breaking down the concept on what a tuned mass damper is, as well as go in depth on how they work, including the mathematical equations used to describe the motion and forces they experience. Our group members consist of Rafael Mesa, Eduardo Nasancieno, Steven Tan, Eric Sauceda, and Saeed Habib. Our goal is to provide the viewers with more information on tuned mass dampers by showing a simulation on what occurs in the system. Tuned mass dampers reduce the amplitude of mechanical vibrations, preventing damage and failure. For example, consider a door that uses a spring to close the door once open. This can lead to any of the above types of dampening depending on the strength of the damping. If the door is undamped, it will swing back and forth forever at a particular resonant frequency. If it is underdamped, it will swing back and forth with decreasing size of the swing until it comes to a stop. If it is critically damped, then it will return to a close as quickly as possible without oscillating. Finally, if it is overdamped, it will return to a close without oscillating, but more slowly depending on how overdamped it is. Different levels of damping are desired for different types of systems. There are multiple versions of tuned mass dampers, and they all have their own functions. However, for our presentation, we are going to focus specifically on high-rise buildings. There are currently 32 skyscrapers worldwide. The US currently uses 13 out of the 32 skyscrapers. The following are famous skyscrapers where tuned mass dampers are used throughout the world. Here we have 3 skyscrapers: the City Crop Centra in New York, the Burj Al Arab in Dubai, and the CN Tower in Toronto. The Burj Al Arab alone has 11 tuned mass dampers within the building.
The picture on the left is the model of our prototype of the building with tuned mass damper attached to it. After making the model, the equation is on the right hand side. The experiment apparatus consists of a moving table, a mass system, and a small building. The displacement is applied by my friend to move the table. The tuned mass damper is placed on top of the building. Numerical analysis were performed in MATLAB to better understand the TMD to mediate the vibration, to observe the variances in forces as frequency of the induced force varies. By obtaining graphs from transfer function, it is clear that the force is harmonic and varies with the frequency of applied force. Both the amplitude and the period of the force are different for each given case. Presently, the greatest concern is whether the TLD can produce a force large enough to the dynamic response of the structure. The largest theoretical force produced occurs when frequency is set to 0.99 Hz. The maximum amplitude calculated for force is 191.406. It is important to note that the force is not symmetrical direction. The case with most symmetry is when frequency is 1.01. Ultimately, the goal of tuned mass damper is to constantly opposed argument the dynamic response of the structure.
So to get a better understanding, we have built our own skyscraper model to give a visual representation of the effects of a spring mass damper on an isolated system. On our left side of the screen, we have tightened the bolts connecting the damper to the skyscraper model so that it acts as a single mass system with no damping. This prevents the damper from having any relative motion to the model. On the right side, we have loosened the bolts connecting the damper so that it may absorb some of the mechanical vibration the system experiences. The damper will then help reduce the maximum amplitudes that the system experiences. As you can see, that without the damper, the building's amplitude of vibration is larger, and therefore the building is isolating at its max amplitude. This was all caused by the given input force by our group member Stephen. Thank you guys for watching our video. We hope that through our presentation, viewers will have a better understanding of how a tuned mass damper works on a high-rise building.